lesson 11, the gist is we know how to, or we should know how to add pretty and subtract fractions fairly easily now. Fairly easily. I don't think that's correct English, but today we're going to use something called estimating. Estimating is glancing at an addition subtraction problem with fractions and kind of making some assumptions just based on things that we know and understand. So in your notebook, you should have Unit 1, Lesson 11. In your notebook, you should have the lesson date and the lesson objective written. And basically, you just need to jot some of these things down, but I am getting this from our class book page. I think it's 23 and 24, I think. 25 and 26, sorry. I knew you guys would know better than me. So there's a couple of different ways to do this. You can use your benchmarks, things that you know, as a basis for your estimating. So in other words, you see this line here. Here is basically a whole. This right here is a whole. Are you with me? No matter which way you divide it up, no matter which way you break it up, it's still a whole. So looking at this one right here, 1/4 plus 7/8. Don't start doing the adding. Just look at it for a second. What is 7/8 almost? Just knowing, basing off what you know on your benchmark here, what is it? Yell out loud so it's in the microphone. 1. So you kind of can think that this is 1 and 1/4, thinking of your benchmarks, all right, thinking of this visual. Okay, so could we estimate 7/8 plus 1/4? What do you think it's approximate? 1, I'm hearing 1, maybe like 1 or 1.5. Something, it's close to that. What's the real answer? 1 and 1/8. So if I were to do that, I'd have to get a common denominator, which would be 8 times 2, 2 eighths, 2 over 9 eighths equals 1 and 1/8. But if it was asking approximately, like if you're talking about fabric, let's say, you need 1/4 of a yard, and you need 7/8 of a yard. You need approximately 1, you know it's going to be over 1, because you know that 2/8 is 1/4, right? Just because of our knowledge of our benchmarks. So in your notebook, you could write 1 plus 1/4, 1/4 plus 7/8, write estimate and a sum next to it. That gives you an idea of what we were doing. I'm going to do another one, basing it off of our benchmarks, and then we'll find the actual sum. So if we were looking at, I'll let you write that. So let's do another estimating one, and you're kind of looking at this hole up here. If you're looking at the hole up here or looking at your hole on your mat, okay? So you have 5/12 and 7/16. So you're taking 5/12 away from 7/16. Well, what do I know about 7/16? It's almost half, because 8/16 would be exactly half, right? And 5/12 is almost half. So I would be taking away almost half and almost half. So what do you think my estimate should be for that one? I'm personally feeling that my estimate would be 0. Because 5/12 is almost half, and I'm taking it away from 7/16, which is almost half. So my estimate would be 0. Now, let's figure out the actual difference. The actual difference, I'd have to come up with 7/16 and 5/12. I, of course, have to come up with a common denominator. So common denominator is 48, which means I have 21/48, take away 20/48. It's 1/48. So that's the actual difference, which is almost 0. So our estimate, just using benchmarks, just using the actual visual, you should be writing this down in your notebook. I'm just making sure because I see a lot of you staring at me. Can you try number 3 on your own? So you have 5/6, which is what? Almost 1, plus 9/10, which is almost 1. What would your estimate be? 2. Good job. So if you're actually, truly adding these, 5/6, 9/10, I'm going to go with 30, friends, as mine. So I have 252/30ths, which is 1 and... So the question is, how did we get to 1 and 11/15 to 1 and 22/30? You have to divide by 2, because 2 can go into 22 11 times and 30 15 times. So we just used our benchmark without the mixed numbers. When you throw the mixed numbers in, you have to start rounding. You have to start rounding a little bit. So, oops. You have to look at, estimate the sum or difference by rounding each mixed number to the nearest whole number. And you're going to use your knowledge of that whole again. So like 5 2/3 is 2/3 is almost a whole one, right? So could we round that 5 to 6? Okay. What about 3 1/6? What are we going to round that to? Do you think we could just round that to 3? Okay. So our estimate might be around 3. Do the actual subtraction and find out the actual answer. You're right. The difference is 2 1/2. But if you were to round 2 1/2, what would you round it to? 3. Do you see how the rounding is it kind of checks yourself? It's a way to do this. We used rounding yesterday with Boy Scouts when I took them to the grocery store and they were trying to figure out sizes of things and prices of things. We use rounding there. You can use rounding. Yeah. So 1 1/4 or 2 7/10. So what would you round 1 1/4 to? 1. Okay. Plus 7/10. That's kind of over half. So maybe we're going to round that up to 2. Well, it's 2 7/10. So it's 2 and over a half, because 5/10 would be half, right? So how about 3? So let's estimate 4, and then do the actual sum. Okay, the actual answer is pretty darn close. 19/20. That's kind of crazy. It's like a sliver. It's a sliver. All right, let's do one more before the bell rings. 3 3/8. That's just shy of half. So what should we round that mixed number to? You want to raise it up? Why don't we do 3 take away 3/16? That's teeny tiny. So let's estimate 4 and do the actual difference. Oh, Mrs. Crane can't. Mrs. Crane's hungry. Must be almost lunchtime. So our estimate is 2. Do the actual subtraction. So are you seeing? Let me wrap it up. Are you seeing how using an estimate or using a benchmark is a good way to quickly check your addition or subtraction on a fraction problem? Okay, in Think Central tonight, because I've already previewed Think Central, read carefully, try your best. We're going to revisit this again tomorrow, so don't fret. And remember not to get help from your families, because I want to know your brain thinking, not your parents.